Welcome back to another past paper walkthrough video. This is OCR MEI Core 1 2015. And if you're not doing the MEI paper, then turn away because I do not want to waste your time. And in this video, I'm going to cover the section B. So let's start with question 10. You're given that a function of x is x plus 3 times x minus 2 times x minus 5. And the first part will be sketching the curve. Show that the function can be written as x cubed minus 4x squared minus 11x plus 30. Then describe fully the transformation that maps the graph of fx into gx, where gx is x cubed minus 4x squared minus 11x minus 6. Finally, show that g of minus 1 is equal to 0, and hence factorize g completely. So let's start off by sketching the curve. So first of all, prepare your axes, vertical and horizontal axes as x and y axes. Make sure you label your axes, y and x. Now f of x is x plus 3, x minus 2, and x minus 5, which shows that the x intersections are located at the solution for x. So if this whole expression is equal to 0, which means that y is on the x-axis, then the solutions are respectively x equals minus 3, x equals plus 2, and x equals plus 5. And therefore you can mark on the spot, this is minus 3, this is plus 2, and this is plus 5. This is just a sketch, so you do not need to fuss about where the crosses actually are. And we know for a fact that this is a curve of cubic, and therefore the general curve of cubics looks sort of like this. Goes up, reaches a maximum, go back down, and goes back up again. This is just a curve, and make sure that it actually goes through the dots that you have specified. Or sometimes it's better to just draw the curve than mark the point of intersection, if that helps you a bit more. And also, it would be rather good to mark the y-intercept. And the y-intercept is simply the multiple of all the last values. So it is 3 times minus 2 times minus 5, which gives you plus 30. And so this y is a plus 30. And that would be a acceptable sketch for part 1. Okay, now part 2 is simply just expanding this whole expression. So it is x plus 3, x minus 2, x minus 5, and just completely expanding these three brackets. So first of all, deal with the first two. So it would be x squared plus 3x minus 2x minus 6 multiplied by x minus 5. And by simplifying the whole expression, you get that x squared plus x minus 6 multiply by x minus 5. Then you just simply multiply everything out using either the Crab law or whatever you want to get that x cubed plus x squared minus 6x minus 5x squared minus 5x and plus 30. And if you simplify every expression, you should get x cubed minus 4x squared minus 11x and plus 30, which is the given solution of part 2. So that is the thing that you're looking for, and you have proven that at the left hand side of the expression is equal to the right hand side of the expression. So for part 3, we want to show the transformation from fx to gx, and we know from previously part 2, fx is equal to x cubed minus 4x squared minus 11x plus 30, and gx is given to us by x cubed minus 4x squared minus 11x minus 6. And the transformation of this is pretty simple because it is the only thing that changed is the constant value on the equation, and this constant value always represents the y-intercept value. And so because everything before it is the same, the entire curve is shifted upwards and downwards, so there are no difference in the shape of the curve as well as the horizontal position of the curve. So it is a straightforward translation curve, and a translation curve have a notation of a vertical bracket of 0 horizontal displacement and a value of vertical displacement. And to find the vertical displacement, you consider the y-intercept, so you have the original curve crossing the y-intercept at 30, and you have a transformed curve crossing the axis at negative 6. And so the total difference between these two are 30 minus negative 6, which is a 36 difference. But because you are transforming towards the bottom side, it is a negative value, so you get a minus 36 transformation, and this will be the correct notation for the answer to part 3. Note that you are also required to state that this transformation is a translation, and so if you miss out this key phrase, then you will not get 1 mark out of the question. And finally, show that g of minus 1 is 0. That is the easy part, because g of minus 1 is just the same thing, but x is minus 1. So minus 1 cubed minus 4 times minus 1 squared minus 11 minus 1 minus 6 will have to be 0, and that's what we're trying to show. So minus 1 cubed is just simply minus 1, and subtract the 4 times a positive 1, so it is still subtract by 4, and this is minus 11 multiplied by minus 1, so that is add a 11 and just subtract by 6, and minus 1 minus 4 minus 5 and minus 6 is minus 11, so you get minus 11 plus 11, which gives you 0. So we have shown the first part of the question, and now we need to fully factorize gx. So in order to factorize an expression, you will have to use the vertical division method. So x cubed minus 4x squared minus 11x minus 6, everything divide by the solution, and we need to find at least one root. And thank you for factor theorem, which this question is ultimately dependent on. We know that when x is minus 1, there is a solution. So because x is equal to minus 1, a root have to be x plus 1. And so x plus 1 will be put on the root, and we have to divide everything through. So in order for this to get an x cubed, we need to multiply by x squared, and so this would be a x cubed plus an x squared, and this would give us minus 5x squared. Now put this minus 11x down, and we have to multiply this value by minus 5x in order to get that minus 5x squared, and you minus another 5x from here, and minus, so minus 11x plus minus 5x gives you a minus 6x minus 6, and that is a straightforward minus 6 on the top, and that would give you minus 6x minus 6, and that would end the vertical division, and you get a partial solution where you have an x plus 1 multiplied by the expression x squared minus 5x minus 6, and this part is a quadratic that is easily factorizable, and therefore the solution of the whole question will be x plus 1 multiplied by a x squared minus 6, a x minus 6 times a x plus 1. So x minus 6 times x plus 1, and note that this and this are identical, and therefore you can just write x plus 1 all squared x minus 6, and that is the solution. So looking back, this question is a 12-mark question, and it is a pretty long one, but it's not that difficult. So if you can break down every single part of them, then you should be fine doing section B. All questions in section B are pretty similar. Now for question 11, we have a circle. Shows a sketch of a circle with equation x minus 10 squared plus y minus 2 squared equals 1, 2, 5, and center C. The points A, B, D, and E are in the section of the circle with the axes. And part 1 is write down the radius of the circle and the coordinate of C. Part 2, verify that B is a point 21, 0, and find all the other intersection points. And finally, find the equation of the perpendicular bisector of BE and verify that this line passed through C. Now this part will be a bit more tricky, but it's worth 6 marks. So let's get right into the question. Okay, so part 1 is just find the radius and the point of the center point. And conveniently, the question gave us the equation of the circle using the general solution of the circle, which is very helpful because we know that the x coordinate of the point C is the solution for the answer of x, and the position of the y coordinate of the center is the solution to the y of this equation, when it is equal to 0, that is. So x minus 10 is 0, and so x is equal to 10. where y is equal to plus 2. Yeah, both are positive, and therefore point C have the equation of 10. Well, it's not an equation, the coordinate rather. C have the coordinate of 10, 2. That is one part done, and the radius is the value on the right hand side rooted, because the general equation is x minus a squared plus y minus b squared equal to r squared, and r squared is equal to 125, and therefore r is just the square root of 125. And the square root of 125 is 5 root 5. So we know that now r is 5 root 5 and center point is 10, 2. That is the first part done. And now we need to verify that b is 21, 0. So in order to find b, we need to find the x-intercept. So in order to find an x-intercept, y have to be 0. And therefore the equation x minus 10 squared plus 0 minus 2 squared is equal to 125, and therefore we just have to expand everything. So that is a plus 4, so minus 4 is 121, x minus 10 squared, and 121 is conveniently 11 squared, so x minus 10 is 11, and therefore x will be this, because we have square rooted, is plus or minus 11, and so the value of x will have to be either minus 1 or a 21. And in this case, because b is on the right hand side, it's the more positive value, which is 21, and therefore x coordinate, well, the value of b is 21, 0. And since we have found the answer to point b, we can find the answer to point a, because point a is also on the x-axis, and the entire calculation that we have done over here can be used, because there's another value for x which is minus 1, and therefore a will be equal to minus 1, 0, and that is one part of the 3 done. So let's head on for D and E, where we need to sub in x is 0. Alright, so if we sub in x is 0, we get that minus 10 squared in bracket, add y minus 2 squared is equal to 125, and we know that this is equal to 100, so you subtract both sides by 100, you get 25 is equal to y minus 2 squared. Again, conveniently, 25 is a square rootable integer, and so you get a plus or minus 5 as y minus 2, and therefore the answer for the solution for y is just 2 plus or minus 5, which is either 7 or minus 3, and therefore the coordinate of D and E are respectively 0, minus 3, and 0, 7. And so we have the solution for B. We have verified that it is 21, 0, and we have found A, D, and E. So that is part 2 of this question. So the last part, which is the most tricky part, is that you need to find the perpendicular bisector of BE. So first of all, let's find out the gradient of BE. So the point B is 21, 0, and point E is 0, 7. And conveniently, we have an x value and a y value, and therefore on the graph it would look as of this is 21, this is 7, and therefore the gradient of this will be a decrease of 7 over a horizontal distance of 21, and that will simplify to a gradient of minus a third. So that will be our M for BE. And in order to find the perpendicular bisector of BE, we know that it is perpendicular to the line BE, and therefore it is a negative reciprocal of minus a third, and therefore the M of the perpendicular bisector, I'll say PB, will be equal to a plus 3. And so because it is a straight line equation, we can fill in y equals plus 3x plus c. Now we want to find the midpoint of BE in order to see if this equation crosses point C. So to do that, you need to find the midway point, which is just half the change of x value from the center, which is 21 over 2 and 7 over 2. That is the point where they where it is at the midpoint. So if you sub in these value into the equation, you can find this specific equation by finding the c. So y is 7 over 2, which is equal to 3 times 21, that is 3 times 21 over 2. So that is 63 over 2 plus c, and you can just for the reason that I want the mathematics to be a bit easier, I multiply both sides by 2 to get 7 is 63 plus 2c, and you can find that 2c is 7 minus 63, which is not a particularly beautiful number. That would give you 56 minus 56 as 2c, and therefore the value of c is equal to minus 28. So we get that the equation is y equals 3x minus 28. So this is the perpendicular bisector of the equation, and now we need to show that it will cross point C. So in order to prove that this perpendicular bisector crosses point C, we need to put in the value x value of the point C to show that the y value of this line is also the y coordinate of C. And as we have found in previous parts, that the coordinate is 10, 2. And so if we sub in x is 10, y is 30 minus 28, which is equal to 2, and that satisfies the y coordinate of point C, and therefore point C lies on top of the perpendicular bisector of DE. And finally, to the last question of the paper comes question 12. Part 1, find the set of value of k, which the line y equals 2x plus k intersects the curve y equals 3x squared plus 12x plus 13 at two distinct points. Then part 2 is expressed that 3x squared plus 12x plus 13 in the form of a times x plus b squared plus c, and hence show that the curve 3x squared plus 12x plus 13 lie completely above the x-axis. And finally, find the value of k, for which the line y equals 2x plus k pass through the minimum point of the curve y equals 3x squared plus 12x plus 13. This question looks horrible, and let's get right into it. So before you start doing anything of this question, you have to understand what you're trying to do. If not, you'll just be very miserable. So first of all, let's decipher the language of this question. So first of all, you have two equations. One of them is a parabola with 3x squared plus 12x plus 13. So it would look a little bit like this. And the thing is, this doesn't have to be the minimum point, but it doesn't really make a difference until because we're continuing this question using the idea that we have now a straight line passing through the curve twice. So it would look a little bit like this. And clearly there is a solution right here, and there's a solution right here. That is two distinct solutions. But if you shift this curve down a little bit, it is possible that it will meet the curve at only one point, which means it is tangent to the curve, and there will only be one distinct solution. Or even it can be way down here, which will not even touch the curve. So the question is asking for the equation, the values of k, where y passes through this parabola twice. And the only place that can happen is when k is larger than a particular value, and we're going to find that particular value in the form of inequality equation. So remove these lots of idea craft and start our equation manipulation by just equating both equations, because this is just how we do algebraic geometry questions. So it's just equating both sides, both equation, and move everything to one side, so that you get 0 equals 3x squared plus 10x plus 13 minus k. Now, how would there be two solutions to this equation? The only reason that a quadratic equation have two solutions is because when you put it into the quadratic formula, which is x equals minus b plus or minus root of b squared minus 4ac all over 2a. The only reason is this plus and minus sign, and if you have done enough of quadratics, you will know that in order for a solution to happen, this discriminant part have to be 0 or positive. If not, if it's negative, then they wouldn't touch each other, and there will be no solution. But if they are 0, the discriminant b squared minus 4ac is 0, then there will only be one solution, which is the point at which the straight line is the tangent of the curve. And so there can only be two solutions to this equation if this surd is a positive value. The magnitude of the surd is a positive value. So b squared minus 4ac have to be positive. That is our clue to this, how to solve this equation, how to solve this problem rather. So put that in mind, we have to show that the root of b squared minus 4ac is larger than 0, and we can just square everything because 0 squared is still 0, and so we get that b squared minus 4ac have to be larger than 0. Now we can do some math by putting in the value of b and a and c. So b squared is 10 squared, which is 100, minus 4, a, which is 3, and c, which is 13 minus k, have to be larger than 0. And we know that 100 subtract by 12 times 13 minus k is larger than 0. And simplify the following into a 156 plus 12k is larger than 0. Now we can rearrange everything. 100 minus 156 is just a minus 56. So we add both sides by 56 to get 12k is 56, and therefore k have to be larger than 56 over 12, which is also the same value of 28 over 6, which is also 14 by 3. And that is the solution for, well, it's have to be written in the form of k larger than 14 over 3, and that would be the simplified answer. Alright, so second part requires you to use completing the square of this expression. So first of all, we should find a by factorizing 3 out of the equation. So y is equal to 3x squared plus 4x and plus 13, and this is out of the bracket so that you don't need to divide this by 3. Now you need to do a half of this coefficient of x to get b, the value of b, where y is a x plus b plus c. This is the form they want. So in order to get b, you use half the x coefficient, so it is x plus 2, that's half of 4 squared. Then remember that you need to take out the factor of 4, the value of 4, because a positive 4 is generated in this bracket where it was non-existent, and therefore you need to add a 4. But remember that this is in the bracket beforehand. You have to multiply it by 3 as well, and the 13 just follows, and y is equal to 3 times x plus 2 squared plus this have to be a negative 4 because a plus 4 is generated, so you have a plus 13 minus a 12 because 3 times 4 is 12, and you get that 3 times x plus 2 squared plus 1 is y, and that is the form that they want. And in order to show that this whole thing doesn't go below the x-axis, we need to find the minimum point that this curve will ever go, and the smallest value that this can achieve is when x plus 2 is 0, and it doesn't matter if it's a positive or negative number because it's squared, and therefore the magnitude have to be as small as possible, and the smallest magnitude you can get is 0, and therefore 3 times 0 plus 1, and y minimum y will be plus 1, and therefore it is the y value will never be under 0, and therefore it cannot go below the x-axis. Okay, for the last part of this paper, we need to show that find the value of k from this equation, that if this y equals 2x plus k pass through the minimum point of the curve y equals 3x squared plus 12x plus 13. So we know that the minimum point of y is have the y coordinate of 1 from previous, and therefore we have a something value 1 as the minimum point. So actually, in order to find this minimum point, you can use the part that is given to you. The only way that this value can be as small as possible is when x plus 2 is 0, and therefore the value of the x value will be minus 2, and that is the minimum point. There's another method of finding out the minimum point. Given that this is a quadratic, you can use a single differentiation, which you should have not learned yet. But if you have learned differentiation, then you should be able to do a single differential to find the stationary point, and in turn that stationary point, since this is a quadratic equation, will be the minimum point, unless it is a negative parabola, which it will be a maximum point instead. So right now we have the minimum point, and we want to find the value of k where this equation satisfies the point minus 2, 1, which is very straightforward. You just put in y is 1 and x is minus 2, add k and rearrange to find k, so that would mean that k is equal to 5, and that is the last final answer for this past paper. And that's it. This is core 1 done, and if you have learned something or if you're not certain about anything, please do comment in the comment section below. and if it did help you, make sure to leave a like. And if you have any other things that you want me to perhaps do, perhaps another past paper or a particular topic that you want me to explain, feel free to let me know again in the comment section. So I will see you in a future video. Thank you very much for watching.